minutes. I'm gonna write down that criticism. Didn't start too early.
Probably at 7:35. You know, there's gonna be a shell.
John hasn't accepted it on the other one.
See, I used to have somebody up here with me. Oh, welcome to 2022, everybody. Yay. And for those at home,
I think we need to click on that.
It's January, which also means it's budget night and presentation night and all sorts of fun stuff. For those of us at home, you can use headphones, please. Please remember to mute your microphone when you're not speaking, although Krista will probably put the bananator on you. If you do not want to be seen, you can mute your video. I know that there is a such thing as Zoom fatigue. If you've never heard of it, it's looking at yourself on video for several hours a day. It is very tiring. It's an actual condition. You can change your view to side by side, which is what I did with this computer. You can raise your hand to the icon. Krista, you're going to monitor hand raising for me. Thank you. To file a motion, members, please unmute and state your name. To vote, members, use the raise the hand button. Thank you. Do we have any guests this evening? How do I, one of these?
Sure, just push away. I don't know which one works.
Okay.
Darkens the screen, but
They can see that one better than that one, unless it's just the angle, right?
I can see that one better.
That's weird. It must be a brighter bulb on the newer one. That one probably doesn't get used as much. So do we have guests?
We're a non-resident member.
Not a guest? You're a member. What's your name? Oh, no, yeah. Yeah. Welcome. Just joined.
That guy mentioned, Yadira, she was gonna be here with me today in person, but she had work.
Oh, okay. So how did you find OAS?
I just Googled Omaha astrophotography and Omaha astronomy in the Google and Facebook, and this popped up.
Nice.
So I went to the website and went to the Facebook page and just kind of.
Good. Well, whatever we're doing, it's working. All right. Is there anybody in the Zoom chat that's guests? Okay. So as a member, you probably have already read this on the website, but you will also be a member of the Astronomical League, and you'll receive a copy of the reflector. It's quarterly. You'll get access to our Astro Park in Weeping Water, Nebraska. We have a great telescope loan program where you can try to telescope, observe, try and experience the different ones. We have our monthly newsletter, the Stella. And of course, you've already been in Discord because I got you yesterday, and members can make and vote on motions during business meetings. Okay, this is going to be fun. I had written up an entire spring meeting schedule that went into the Stella. Policy has since changed at UNO today, and we will not be meeting here next month. We'll be back on Zoom. So they've gone back down to a limit of 25 people in the school, but no co-sponsored events, which would be us. They also reiterated no food in the same announcement, but can't do that anyway. So what I put for February 4th is no in-person Zoom meeting only. I think things are going to be malleable. I don't want to commit to March yet, so we'll assume it's a hybrid, but just plan it might be Zoom anyway, just in case. Then we'll kind of see how April and May goes. Our contract for this season is through May, so putting that out there. It's sad, but we do what we can. Oh, the MISRAL conference is coming up. If you don't know what MISRAL is, it's the Mid-States region of the Astronomical League. It's our chapter, as we are in the state of Nebraska. Is going to be hosted by the St. Louis Astronomical Society in St. Louis. It's going to be June 2nd through the 4th, 2022. That's kind of the confirmed dates. I mean, the date I saw in November said the same thing, and then the most recent email John forwarded to me was also the same dates, but they're still looking at the location. So I think it's going to be in 3 separate locations from what they said in the message. So it could be interesting. They just have to firm stuff up. Yeah. So if you've never gone to MISRAL before, it is a nice event. They obviously haven't had it for a couple of years. Kelly and I, Bill, John and his wife, we went down for the one in Kansas City. Right, the last in-person one. And we had a wonderful access to the technical library there. Some of those books were hundreds of years old, and just being able to look at them, we couldn't touch them though. That was just the curators could touch them, if I remember correctly. But just fascinating. And it's just everything in that library is all technical materials. And their book vault is just, it's all climate controlled. It's really thick glass. Actually, I have a picture of John looking through the window into the vault, but you can just look through the windows and just see all these old books in there. It's really neat. The University of Washington, no, Washington University, got to refer that around. In St. Louis is one of the locations where they are probably going to have parts of this. We don't know about accommodations at the moment. I don't want to make any promises, but hopefully that gets firmed up in the next month and we can present that information, because we all want to make plans for that as to where we're going to stay, things like that. Did we have anybody go to Astro Park in the last month? We did. I don't think he's online, but I know at least one person did, because they were down there last week doing photography. I'm just going to say 2. Yeah. Oh, awards chair already. You don't want to be on microphone, right?
Well, I don't know. I'm not very good at projecting, so I might as well use it, I guess.
Put that first.
I'm not very good at projecting, so I guess I'll use this. Can everybody hear me?
Try it again.
I don't think it's on. Oh, there we go. Now it is. Okay, so yeah, thank you. I'm super excited to present a couple of awards tonight. And both of these members worked really hard and observed a lot of objects and documented all that good stuff. Okay, so the first one that I want to present, this member observed asteroids, and he observed 25, I think it was. Actually, I think it was, might have been 26 exactly, but the minimum for the award is 25. So this member, his name is Jeff Purcell. See if he's here tonight. Hey, so Mr. Purcell, please give him a hand as he comes on down. So you have an award certificate here for the Asteroid Observers Program. What's that? Oh, Louis is going to do a picture. Is that okay?
If you want to get on camera.
If you're out of the camera, but take the picture first and then from there.
Okay.
Okay, we can shake
Everybody
hands if you
here,
like it.
and look this way, smile.
Hold it so that you can see the
Smile.
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 You can't see that smile.
And
Smiley.
So the asteroid observers program, Mr. Purcell worked very hard, obviously, to locate those asteroids, document them. And then we turned those in to the awards folks there. Thank you. And they approved it and sent us the certificate. So thank you very much for your hard work in doing that. Please give Mr. Purcell a hand. And I'm excited that we have actually 2 awards. So we have Mr. Purcell's and one other. It's like a kind of a surfeit of awards right now for a long time with no awards. So I love it. And I hope we get more to come in the future. Okay, so our next award, our member here observed, you guys, not more than 400, I should just say, 400 deep sky objects and documented all of those as well. Bill Bond earned this award. Yeah, 400 deep sky objects, you guys, if you can imagine. That's a lot of nights at Astro Park. Really, really cool. So tell him congratulations when you see him at the break. Ask to check out his really cool pin because he also got a cool pin along with his certificate. This one came with a pin. So it's really cool stuff. We're very excited. Thank you, Bill.
Thank you, Kelly.
Oh, we gotta look this way. Smile. Thank you, Louis. Thank you, Bill. And
Thank you.
thanks for your hard work. That is super cool.
Thank you.
Very neat stuff. I have to imagine Bill knows the night sky really well at this point. Oh, actually, they also sent a letter. I'm sorry, I almost forgot about that. Thank you, John. So they sent a letter that goes along with this. It says, "Dear Bill, congratulations on completing the requirements for the Herschel 400 observing program. On behalf of the Astronomical League, it is my pleasure to send your certificate and pin. Display them proudly. This is a significant accomplishment. The effort you've put into the observing program should be a great help to you as you move onward to additional celestial wonders. We hope you'll continue to explore the many deep sky wonders on the Herschel 2 list, as well as other observing programs available to you from the Astronomical League. Have many clear nights." So you can also take that with you. Did you want the folder to go with that?
Well, if you need to keep it,
I don't need to keep it.
okay,
You can take it if you'd like.
that'll protect it a little bit.
Absolutely. Awesome.
All
So
right.
yeah,
Thank you.
thank you very much. Just gonna say, nope. I was just gonna say, this is a great time to check out the awards and, oh, the website was up there a second ago. But it's in the Stella too, you guys. So you can ask me if you need to find it. But definitely check out the awards. There's so many different kinds. You can, as a member, put in for, and they all have different requirements. So you kind of have to look through and see what would work for you. What you like. They have everything from sort of beginner level to the more advanced. So it'd be a cool thing to do for 2022. And I encourage everybody to take a look and see if there's something that would interest them. So that's all I have.
So try to find the asteroid one too.
Oh.
There it is.
Yep, that's an alphabetical list right there.
Great. Thank you, Kelly. Sorry, that's noise. I put that back in there. Oh, let's see. Do, 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 do. What's next on The Price is Right? Observing chair. I need to get back to my sharing options so you can see presentation. I'm just going to say the whole thing.
All right, so January 2022, happy New Year. I have to say I was so caught up in 2021 because the first set of slides I sent to John said January 2021. And then I realized, wait, it's 2022. So here's Jan 2022. Hopefully it's not a repeat of 2021. But we still have a lot of planets that we can see. Venus in the evening sky, though it's much lower, it sets about 1 hour after sunset. inferior conjunction here soon, and so by the end of the month, it'll be closer to 1 hour before sunrise. Mercury is still lower, but it's close to Saturn on the 12th and 13th, and it has its inferior conjunction on the 23rd. You can still see Saturn and Jupiter, so there's a lot of planets that you can see. Neptune all at once, Uranus, Mars in the morning, and on Jan 29th, look for a good sort of conjunction of Mars, Venus, and Moon, though technically, I think they're more about 10 degrees apart, each of them. Provided it's not cloudy or too cold.
Next.
Next week.
Oh, sorry.
New moon, Jan 2nd, of course, now today's Jan 7th, and the full moon is on Jan 17th. I did put a link in there, that's from inthesky.org. They have a lot of fun links, and this is good to understand what you can see in the morning sky, evening sky, and you can play around with this. You can magnify it or minimize it to see the inner planets or the outer planets. And that has a little key there as to what's in the evening sky, and gives you a great idea of where the planets are in relation to the sun, the day and night, to figure out why you see when you see it. So it's really a nice little graphic, and you can spend quite a lot of time playing with it.
Oh, the grid changes there. So
Mhm.
Yeah.
AU to 2.5.
There are a couple of comets that you could look at, but I don't think any of them are real binocular objects. In December, I know a few of us did manage to, I would say, sight Comet Leonard. I don't know that I want to say it was brilliant and easily visible, but I think it's out of our skies now, at least for the Northern Hemisphere. That's it.
Great. Thank you, Sonali.
Outreach,
That about sums it up right there.
right there, one outreach.
If the weather cooperates. It doesn't look, the 5-day forecast doesn't look too bad, but
They said it's supposed to be drier next week.
yeah, it's supposed to be, well, Wednesday's gonna be nice, but Tuesday is. We'll see.
Okay.
John, I probably will try to be there. It looks to me like the moon will be visible and the temperature won't be terrible. So if someone shows up, I'll be around there a little bit.
All right,
Cool.
I'll try to if it looks promising.
Telescope and binocular loan program. Give me the,
Steal some words from Prairie Home. Start this over again. I say to steal some words from Prairie Home Companion. It's been a quiet month in the telescope loan program. Coronado came back early December and it promptly went back out. And
Because the sun's been hiding and it's too cold.
well, I offer no editorial comments. And one of the 10-inch Dobsonians went out. For any of the ones that have been out there for a little while, if you want something that's been checked out, give me a yell. We'll try to retrieve it. So that's about it.
thank you, Stafford. Jordan,
Hello.
how are you?
Pretty good, pretty good. Good to see everyone here. For tonight's program, I'm really happy to say that Mr. Steve Skinner will be giving an intriguing presentation on space telescopes and some of the newest stuff that we can find out in our nearby outer space realm. Been talking with him for a while about that, and I'm pretty excited to see what he has to share with us tonight.
Nice. Thank you. Let's see. Do we need a break or do you just want to go right on the presentation? Yes, yes, Louis. Is there a tool time? Do you have a tool time? Oh, sure.
Well, unlike Sonali, who hasn't been looking at the sun this month, I enjoy looking at the sun. Can I share? I like to go to the Space Weather Prediction Center, and I recommend going there. swpc.noaa.gov, the Space Weather Prediction Center. This is the home page, and up top center, there's a link called Dashboards. If you go to Dashboards, and under that is Space Weather Enthusiasts. If you go to the Space Weather Enthusiast dashboard, this is the link that I make a favorite, and this is what I go to look at. It has a lot of interesting information every day. In particular, it has predictions of what the magnetic storms might go to if we get up into a G4, G3, G2 storms and all. For Aurora, I like to watch that. There is a live picture of the sun, which is what I go to mostly, but once a month I check the solar cycle to see what the previous month's sunspots are. And you notice that they're just trending up and up and up. We've come out of minimum. We have sunspots out on the sun. It's been, we haven't had this many monthly spots since 2017. We broke over 100 last month. Thought we did. Thought it was 100. Well, 67. But it is good. But what I wanted to talk about in particular is the daily view of the white sun, the solar visible light. And I bring that up. And if you click on the play button, it runs as a movie. And you get to see the sun over the last 24 hours. And you get to watch sunspots form, or mostly they rotate across the disk. There's nothing changing very significantly today, but 2 days ago, this massive group down in the middle changed. The leading spot in the upper right of that group was actually 3 spots well separated, and they merged and flowed together. It was it was fun to watch. But each day you can go there and you can watch the spots as they rotate across. New spots form or dissipate. They move and change into different configurations. It's not as active today as it was about 2 weeks ago when there were 3 groups. No, I think there were 5 groups across the southern hemisphere and 2 major groups up in the northern hemisphere. It was a lot of fun. So I recommend this dashboard and checking it out on a regular basis. Thank you.
What was the URL again?
Space Weather Prediction Center. So SWPC at NOAA.gov, NOAO.gov, and then change to the dashboards and the Space Weather Enthusiasts, and then bookmark that page, and then you're good.
Space Weather Enthusiast dashboard.
Say what?
You can come up with the dashboard on when I Google searched it. So.
Yeah. So that's an easy way to get there. Sonali?
There's also another site that I've watched called Space Weather Live.
Okay,
That also gives the sunspots and the numbers, and you can look at it daily. And it's it's different than this one, but
Yeah.
it also it doesn't give a film like this, but it does give you the spot numbers, and the dashboard that you pointed out also has the synoptic map, which is fun to look at.
yeah, there's lots of, if you like x-rays, if you like other viewings of the sun, there's all kinds of fun things to look at. My particular favorite is white light, just because that's what I like to do with my telescope and all. Oh, I was gonna say one other thing, but now I've forgotten again, so I guess that's it.
Thanks, Louis.
Any questions online? You type them in the chat, raise your hand.
Or unmute and talk. All quiet on the chat front.
All right.
Okay. Let's take a break before we start Steve's presentation. What do you say, like 8:05 start up again? Is that enough? Okay.
Right.
Hooray. You know, if you haven't heard, and Bill talking about this reminds me, one of the wings of the James Webb Space Telescope has deployed for the primary mirror. The second one should be tomorrow. I did see somebody online saying that it should be renamed the Betty White Space Telescope. Because she passed away.
Well, then Sidney Poitier passed away too.
Yes, these things come in threes. All right. My grandmother just had her 103rd birthday.
Congratulations.
Yes. That's a week ago yesterday. All right, Steve. Are you going to share your screen, or are you just going to talk?
What I'd like to do is to investigate the menu on our website a little bit. And then I have some files that I would like to share.
Okay, so you're going to share your screen then? Or you
But
want me to
not-
run the...
I'd like you to go to our website and go to the menu bar.
I'll do it like I'm in tech support.
Okay.
Okay, I'm there. What I want to do is, let's see, I need to share my screen. I want to highlight you. Oh, you did. Thank you. Thank you. Okay. I'm going to share desktop. And you can see the website.
That's perfect. So what I'd like to do is to take a look at some of the menu headings. I don't know if I can do that or if you have to do it.
Nope, he's got permission.
I got it. Or you can do it either way, but I've got it up right now.
Okay, well, the things I'm interested in showing are not very clear at the top, and I can't move that screen. So I'd like to go over.
Okay, I'll let
Why
you
don't
share.
we just share his screen
Yeah,
out?
you go ahead and share, Steve.
Okay, I'll share.
You can remove my spotlight.
Mhm.
All right, then. Well,
Tell him.
okay, but what I'd like to do is to get back to the OAS homepage. I mean, I could do that by calling up an app. I don't know what I have to do here exactly.
Okay, you need to open up Safari on your Mac.
All right, I'll do that.
And you'll need a new tab. There isn't one already there.
Okay. Okay, here we go a little bit, I guess. So one of the things I'm going to talk about space telescopes tonight. And initially I thought I would do that simply because I knew the web launch was going to happen. But the more I looked, it was a little bit like trying to say, well, I'd like to talk about cars. It's just too much. So what I'd like to look at first of all is the monthly meeting.
Okay, when you go at the bottom, in your Zoom window, you need to click share screen.
Oh boy.
It'll be green.
Yeah.
And when you click on that, you're going to look for your screen one or desktop one.
Well, I see when I click on share screen. Okay. I guess. There it is. Okay. Yeah, such a deal. Well, I wanted you to take a look at monthly meeting because my guess is that maybe that particular choice is not visited often. So I don't have any slides to show or handouts exactly, but I do want to show you that it's pretty easy for any presenter to post those things here so that they can be used later. And that really is my intention. Louis gave a talking geometrical optics a few years back, which is very good. And so tonight, my stuff is going to be there under Space Telescope. And the only reason I'm saying this is that my intent this evening is not so much to try to provide information, but rather to provide connections, to provide places where you can revisit and explore on your own. So I have kind of my own notes that I'm going to use in a minute, and I've got just a few things that I'm going to use along the way. So whatever I use tonight, you can find right here and review it later if you'd like to see it. All right. Now what I'd like to do is go to a different spot. I'd like to go to club information. I think that one too maybe is not visited so often. There's information about Astor Park and contacting us, but I'm interested in the newsletter archives. If you haven't visited this, John's done a marvelous job just taking all of the previous Stellas and organizing them. There they are. And the only reason I say this is that starting a year ago, last January, I enjoy writing, and I wanted to write a little bit about some astronomy topics, and in the process of writing, learn about those topics. So for 8 months, I wrote an article in Stella, January through August. I'm going to reference one of those tonight, and I just want to kind of refresh how you can get to a back copy of Stella if that's what you'd like to see. So that's it. I just wanted to talk about those two items. And then what I'd like to do, let's see, I've got one other thing on online resources, not visited very often. But one of the online resources is a collection of links that I put together that John graciously published and has continued to publish each month. And so if you look at the top, there are sort of best links, suns and planets, stellar evolution, cosmic distance ladder, telescope reviews. I mean, it goes clear along the top. And so if you haven't visited that, I think it's an interesting thing. It's a very useful compilation of websites. Now, there's one in particular that I'm going to use to talk tonight, a list of space telescopes. There it is right there. So I have that link and some other links that I'd like to share with you. So John, I'm done sharing the website. What I'd like to do is to share some files on my desktop.
Okay, so when you shared the screen, did you
I've
say,
gotta go. Yeah.
did you just choose the browser, or it looks like you just chose the browser rather than the whole screen?
I don't know.
If
I'd
you
like
if you click on the second tab, are those the ones you were going to show? Click in there.
Okay. Yeah.
So just click on each one.
Okay. Great. It's that's just what I wanted to know.
Sometimes websites are slow, folks.
Yeah. Okay. Well, so here's my little spiel on space telescopes, their diversity and their mission. And so I'd like to, right off the bat, say that line item 10 that you see, and I saw that on that compiled list of links, is where I'd like to go first. And I was just astounded. This is nothing special. I just happened to run across it, thought that it was very good. I would have guessed that maybe there was a dozen or so space telescopes. Egads. I'll just go clear top to bottom. These are all space telescopes. It's just kind of surprising. So I'm going to go clear back to the top because one of the first things that I like to talk to you about. Come back. No.
Just back up one on your browser.
Oh, it's over here on the side.
Oh, okay.
Right here. That's what I want to do. Okay. So one of the things that really interests me about space telescopes, we tend to think that maybe they're all just optical telescopes and just collecting white light and its components. It's not true at all. But one thing that I'd like to show you is that when we take white light and diffract it, put it through a prism, some kind, or a diffraction grating, we separate the wavelengths of light into their colors. And so by doing that, we can access all the hidden information in the starlight. And so maybe these are just optical wavelengths. That'd be easy thing to do for a telescope. But the wavelengths might be as short as gamma radiation, might be as long as radio waves. And so this is instructive to look at, but you need to think about it as more than optical light. It could be all the way from very long radio waves that might be hundreds of meters long to gamma rays that might be extremely short. Okay, let's see if I can get the hang of this. Now I want to go back to
That's all right. Don't.
My favorite, I think, is 3 or 4, but it's underneath the screen.
Yeah, I'm guessing. So let me try this one. No, let me try this one. Yeah, okay. Part of the problem is that what I want to touch is underneath some of the website, Zoom website. Okay, so at any rate, here's this very, very nice collection of all of these space telescopes and what they do.
Really?
I would like to say also that there is a whole organization, Space Telescope Science Institute. That's kind of an interesting thing. An organization that does nothing but manage the output of these space telescopes. So what they are, it really are electromagnetic spectrum investigators. And they do a variety of things for us. They can provide very nice optical images, but they can also keep track of particle emissions, particles in the solar wind. They can keep track of bursts of radio, and I think that we all know that. the interesting thing about the list of telescopes is that you can see all this, what they are, what they do, where they orbit, the names, launch dates, the waves that they're looking at, and when they were terminated. So here are some famous telescopes, a few of them, the ones that are very well known. One of the things that these space telescopes do is try to increase our knowledge of what's called astrometry. Come back. And that is to say, finding the positions of the stars themselves. And so one of the unexpected things I learned about trying to assemble this program was not only are the space telescopes looking at different aspects of the electromagnetic spectrum, but they're also doing it by very carefully engineered and chosen orbits. You know, there's a tendency to think, we'll throw the telescope up in the air and just tell it to point at Jupiter and take a picture, and that's a space telescope. But it's very, very, very much more than that. And so one of the things I'll do tonight is to try to talk, whenever I can, about the orbits for some of these space telescopes. Here's one called, this was a very famous space telescope, Hipparchus. And so here's some information about it. Again, the thing that I really like about this is, so here's the topic I'd like to find out about, the Hipparchus Space Telescope. And you know how this all works. Every time there's some blue text, it's another link. And so that's what I'm really interested in collecting for you. I'd like, if I can, to collect things about space telescopes, make some generalizations, and then make these compile this set of links so that you can investigate yourself. It's not a minor thing to investigate to compile good links. They're difficult to find sometimes. So the part that I really am interested in is over here on the side. And I'm not going to be able to show that very easily. I'll have to just zip by it this way. So this sidebar lists all particular information about the space telescope. And one of the things that I'm most interested in is the orbit. Okay, so this particular space telescope is looking at a particular part of the electromagnetic spectrum, but its ability to do that depends on how carefully the orbit was chosen. So a geocentric orbit is easy enough, we understand that one, but how does it get to a geosynchronous orbit? Oh, jeez. Well, I can't close the window, I can do that. Okay. So here was, I'm going to run this again now that I see how to manage my windows. So the Hipparchus telescope was launched into this orbit, but then a transfer orbit was achieved to give it the geosynchronous orbit that the particular designers of this satellite, of this telescope, wanted to have. And that's a really important thing. So here again is all of the list of the information. And you can see already this is just way too much to comment about, except in a general way. If I go back for a minute, I think I can go back for a minute. If I go back to the link to the space telescopes and linger a little bit more this time, see if we can find Hipparchus. So the first set of telescopes are gamma X-ray telescopes. And you know, for starters, one of the very first telescopes was a little bit like this, looking at this part of the electromagnetic spectrum. And I think what we tried to do initially was not necessarily look at the part you might expect, the visible light. this kind of radiation is absorbed by our atmosphere. It's not very easy to see what we're looking, see what we want to see, because our atmospheres had an effect. Oops. So I want to go down here just a little bit. Wonderful links here. Look at, try to find Hipparchus. Look at these on the way. And again, I should go back up here just a little bit. So the name of the space telescope, the agency that launched, the launch date, and when it was terminated. Well, there's another thing. We probably all know this, but don't think about it much. We spent a lot of money to put these telescopes up, and they have a lifetime. And it's not because they were knocked out of the sky with micrometeorites or something. In order to put them in a position to see what we would like to see, requires some onboard thruster gas of some kind. And so the limit of the telescope is how long it can remain in its orbit and the supply of the thruster gas. If the telescope turns a little bit in a different direction, rotates or aims in a different direction, then the thruster gas will act like a miniature rocket and bring the telescope back lined up to where it needs to be. How much thruster gas determines the lifetime, useful lifetime of the telescope. I think for the James Webb telescope, I think that they have gotten that they can get 5 years out of it. And they think that probably that can be, I'm talking about Gaia now, I think that they can probably get 10 years out of the space telescope, which seems silly, but there's a limit, of course, to how much of this thrusting gas that you can put on board with the satellite. Okay. Hipparchus really did a fantastic job trying to find out where the stars in the Milky Way are, determining the distance to those stars. We have several other telescopes that have done equally a good job with that. And we have some telescopes like the Hubble that are just famous for the visual light pictures they've taken. Here are the visible light ones, and here's Hipparchus, the European Space Agency. Launched in '89, terminated in '93. So it did not get quite 10 years. The Earth orbit given. There are some other satellites that I'll talk about later, Gaia in particular, and TESS, two current satellites that have done amazing jobs with locating where the stars are. Okay, I'm going to go back. So here's this list of first ones. The first telescope in orbit was the Stargazer, 68. That's a long time ago. Hubble looking at not only the visible light, but near ultraviolet. Here's a famous gamma ray observatory, an X-ray observatory, an infrared telescope, and now the James Webb. So it's pretty clear what we're trying to do very diligently is to look at all of the wavelengths of light that come to us and take advantage of what each wavelength can show us. Astrometry, as I said, is the part of astronomy that has to do with finding very precisely what the locations of the stars are. Here's the link to Hipparchus. So bottom line was Hipparchus located 100,000 stars to within 0.02 of an arc second. And so I want to talk about that a little bit. An arc second would be 1/3600th of a degree. 60 minutes in a degree, 60 seconds in a minute. 1/3600th of a degree. And so this is the coin of the realm. If you want to determine where the stars are by parallax, you're going to have to use very, very small angles and be used to manipulating the equipment so that it can look one direction, then another direction. But it may be that the difference in directions is very small. Milli-arc seconds, MAS. It's the coin of the realm. I got to thinking about that, and I got to thinking about something simple, a milli-arc second. All I could think of initially when I heard that term was, oh yeah, I remember her, milli-arc second, graduated from in '63. A very nice person, but a little narrow. Well, oh, you're awake. Well, good. So here's something that I would like to try. And I thought originally, if I was going to do this in person, I was going to get a 4x6 note card. And I thought this would be a good exercise. So how many milli-arc seconds, what angle is there between one side of the card and another? So if I take the card and look right down the edge of the card, the thickness of the card, and imagine a line of sight on the left side of the card. Yes, on the left side of the card that would go to the back of my retina. And then on the right side of the card, that's called subtending an angle. It's a very small angle involved there. Well, I wonder what angle. And so I want to talk about that just a little bit. And I was inspired to use the card because back in the day, Grace Hopper, very famous person who first started trying to educate people about communication satellites and the time that it took, the time lapse that happened when you tried to talk through a satellite. And she was famous because it was just nanoseconds, or microseconds. And she would have pieces of wire that she cut that represented a length that it would take a time, cut the wire so that it would take 1 microsecond or 1 nanosecond. And she, as I say, she was very famous about that. I'm going to show you a picture of her right quick. There she is, Grace Hopper. And she was the person who really was the impetus for the COBOL language. She was very insistent that the instructions for a computer language should contain ordinary words and be understandable. And she had quite a collection of honors. And I'm doing this only because, look at that. She got to be captain and beyond. And so when I thought about that, I thought about our own captain, right? Captain John Johnson, also in the Navy. Well, Grace Hopper was very famous for her cute little way of trying to let people understand how small a microsecond was. And I would like to do the same thing. So I'd like to find a couple of things with this card. So now what I want to do is, and I suppose I can't because maybe I could read this. Oh, I can read it a little bit. Maybe. So I've got now I have some pictures of cards I want to show, John. How do I do that? Light distance, no. Marcus Lista, no.
It would be in that folder that you had originally on the far left.
Oh.
To January. The one
No.
next to the right. One more over.
Oh, it doesn't show on my screen.
It says January on it at the top, right to the next tab over.
I see it.
Just hit the arrow on the right where that red icon is.
Wow. Okay. Well, I'm sorry I'm so dense here. It's just a little confusing.
All right.
Someone's asking a question in the chat.
That was Carol.
Oh, Carol left.
Anyway, here's the free nanosecond. So there's the card. Card happens to be, it's a 4x6 card, 6 inches. And so I just asked Siri, well, give me the speed of light in feet per second. So here it is in feet per second. And there it is. So many feet per second, it's a big number. And what the point I wanted to make here is that's not what I was interested in. I was not interested in the number of feet travels per second. I was interested in the number of seconds per foot. So you just do the division, you divide it into 1. And the seconds turn out right, seconds per foot. And so it turns out that light takes about 1.1 billionth of a second to travel a foot. Well, this little card is a 4x6 card. So pretend that there's a mirror here and use the laser to shoot a beam to this end of the card and have it bounce back. So if you want to try this yourself and carry your own special nanosecond around, then you can do that. It turns out that for a 6-inch card, the time it takes for light to travel across the card and back, 1 foot, is about a nanosecond. Well, okay, that's just a freebie. I just thought you'd be interested in that, but
The arrow next to the icon.
yep. Jeez. What I'm interested in having you see now is to try to figure out for the thickness of the card, how many milli arc seconds is that? The thickness of the card. So here we go. We're talking about arc angles. And so here's the little drawing. Here's the distance of the arc along the arc. But this is such a small angle that the difference between an arc and straight line is not measurable. So there's a little formula that governs all this. The arc length, S, is equal to the radius times the angle in radians. And so if we would like to find the angle, I could take the thickness of the card. Now, I bought a package of 100 cards. It was exactly 2 centimeters thick. So you can do the math there. You could divide. It turns out each card is 0.2 of a millimeter and held at arm's length, about a meter away. Means that the angle from the left side of the card to my eye, back to the right side of the card, is this very small angle. We remember that there were pi radians in 180 degrees. That makes 1 radian about a little over 57 degrees. So I can use that to find out how many degrees that little card, the thickness of the card subtends. It's about 1/100th of a degree. And since there are 3,600 seconds in a degree, it means that the card is 41 arc seconds thick. 41 arc seconds thick. Now, the telescopes that are in space determine distances by using very small shifts in the stars they're looking at. And the shift is generally a few milli-arc seconds. So 41 arc seconds, the thickness of the card, I could convert that to milli-arc seconds because each arc second has 1,000 milli-arc seconds. So another way to look at the thickness of the card is 41,253 milli-arc seconds. So let's really get to the cut here. If I would like to have some feel for how big a milli-arc second is, I should take the thickness of the card divided into 41,000 equal thicknesses. One of those is a milli-arc second. That seems incredibly, like an incredibly small angle. And it is, but I will tell you that the best technology for space telescopes these days determines the shift in stars in micro arc seconds. A micro arc second is 1,000th of a milliarc second. So another way to look at the thickness of the card is, if I would take the card and slice it into 41,253,000 equal parts, one of those parts would be a micro arc second. And the best technology we have with these space telescopes is able to see pretty easily a few micro arc seconds, 5, 7 micro arc seconds. And that it can do that repetitively. So the bottom line that I learned by looking for information about these space telescopes is the incredible precision that they have. Okay. The thickness of the note card, you can have that free nanosecond, my gift to you. You can have that, those free 41 milliarc seconds.
I'm rich.
Good. But there's something else you can do, and that, which is kind of interesting to me. And that is, if you look at our modern devices, the modern, the screens on those devices have pixels and lots of them. So I'm not going to go into this, but you can investigate it later. I was curious to try to figure out if I could see the dots on a retina screen, on a phone or a tablet of some kind, what kind of angle is made there from one dot to the next to the back of my eye. And it turns out that that's with the best, the highest density screens, it's about 9 milliarc seconds. Okay. I want to talk to you a little bit now about, I've got one thing here I'm not going to talk about just to save time. And of course, I was just really funny about this. I thought, well, the card's got 3 dimensions. One side you're using for a nanosecond. The thickness we're going to use for a milliarc second. We got the whole rest of the card back. So one thing you can do for yourself if you're interested is you could draw out the wavelength of the remnants of the Big Bang, the microwave radiation that permeates space that you hear about so much. And if you'd like to have some information about that, it's here. All right, I would like to talk to you about Gaia just a little bit, because Gaia was the telescope that came in terms of finding locations. It was the telescope that came after the Hipparchus telescope. And this one is kind of amazing, I think. The estimation was that the Gaia Space Telescope could find the proper motion of 1 billion stars, that is to say, relative to our sun, how are they moving? Are they moving towards us, away from us? How fast? With an accuracy of about 20 micro arc seconds for a 15th magnitude star, and an accuracy of about 200 micro arc seconds for a 20 magnitude star. Now, again, you read all this and it's just numbers. My hope was that by doing that simple little trick with the card, you could have some feel for how small the angles really are. Here's something that I found is an astounding statement. We have equipment that can do this easily, 7 micro arc seconds. That's no big deal. We do that all the time. And so to put that in perspective, 7 micro arc seconds is the width of a human hair viewed at 1,000 kilometers. That's the precision with which we're locating the positions of stars in the night sky. And if we can be successful with that incredible precision, then we have a chance of calculating by parallax how far that star is away from us. So I want to go ahead and take a look at the website here for the Gaia spacecraft. And what I'm interested in here again is all this you can read for yourself. But I was interested in a couple of things about this, this particular space telescope. Number one, it was going to collect information about 1 billion stars, but not at the direction of us looking. We're not telling the space telescope, hey, look at this one, look at that one, and look at the one in the lower left-hand corner. It's done entirely autonomously. It is the telescope itself that's choosing what to look at. And I have some more information to show you about that. I want you to take a look at the orbit. And there's a very important point here that I like to talk about. And that is to say that it's going to be sent to a special spot in space called a Lagrange point. So two mathematicians really figured into calculating all of this. A German named Euler, E-U-L-E-R, and a Frenchman named Lagrange. Euler figured out these points, and it was Lagrange who figured out L2. And L2 is where most of the space telescopes are sent. And so I'd like to talk about that for a minute. I'm going to go back out of here. I'm going to, if I can find it again. Huh. Oh, I'm lost again.
You looking for your files?
Yeah, there it is. I think.
Should be.
Yeah.
Second tab from the left.
John, I've lost again.
Below the A.
It's in your browser.
Oh.
You got, it's the second tab from the left. So it says Omaha and then January
Below the A.
below the A. The font in your browser bar.
Ah,
You can close some of the ones you don't need anymore. That'll help find the white one.
Yep, they're there almost.
I have to go back and use that spreadsheet thing again.
Oh, just go to the first tab then.
Yeah, but it's not what I want to use right now.
Okay. There is a spreadsheet on the tab on the far right,
No.
all the way over to the right, below the four quad. Keep going to the right.
Here it is right here. The problem is I just wanted to touch the ones I needed, but it's, you know, some of the Zoom.
Right.
Yeah, that's
We're
okay.
only seeing your browser. We're not seeing anything else that you have open.
Well, how about that? Can you see that?
Nope.
Yeah, that's what I was afraid of.
We're only seeing the specific browser window that you have.
Yeah. Okay.
You can change the sharing options if you want, or just reopen it in that window.
I'd like to, there's a picture I'd like to show you. They're on my computer desktop, along with the other stuff.
Then just go up to the top and say File Open.
Okay.
And then find your picture.
All right. That's the one I want. That's the one I want to show you.
Browser.
Can you see it?
No.
Okay, it's because, yeah.
Go ahead and stop the share for the moment.
Yeah.
It's it'll be at a bar at the top.
Yeah. Okay.
All right, so when you click on share screen,
Yep.
what does it tell you?
I'd like to share what's on my desktop.
Right, just tell me what it says when you click share screen.
Desktop, whiteboard, iPhone, Safari.
desktop. And then share that, they click the share at the bottom. That's going to show everything on your machine.
Well,
Well, everything as you see it.
yeah, except that, again, the menu bar for Zoom is covering what I want to choose.
Close them, minimize them or close them.
Okay, I've just pulled it down. So let's try this.
There you go.
There you go.
Can you see it now?
Yep.
Yes.
All right. This is why I really wanted to practice. To practice this live is no good. And I can't practice it alone. So here are the Lagrange points. These were calculated mathematically again by Euler and Lagrange. And what I would like to have you take a look at is it looks like a plateau. These diagrams, you can think about these as sort of potential energy, like the top of a hill. And so these points would be prime targets to put your satellites because it would require less of the gas to keep the position correct. Anytime you vary away from that, kind of fall down the hill, it's going to take a lot more of the orbit correcting propellant to fix it. So these spots look attractive, but they're not so attractive for a simple reason. This arrangement of Lagrange points is a characteristic of any two mass system. Any two mass system. So every planet has its Lagrange points. And the thing about that is that space junk, debris, collects in these Lagrange points. And the famous Trojan asteroids that follow the orbit of Jupiter are in one of Jupiter's Lagrange points. So this is a good reason not to put a telescope there, because it's going to be a stability point for any space rock and junk. And maybe you don't want your telescope in that company. Here's L2 and L1. Look how narrow those places are. So if you put a telescope there, there's a good chance it might fall down towards the sun, if you will. But it means that it will not take very much propellant to correct the orbit. And it also means that all of the space junk that orbits a planet is not as likely to be there. And that's why the telescopes are there. Okay. I probably have to quit this, I suppose. Stop the share, see if I've learned anything. Go to the share again. And what I want to do is to go back to the spreadsheet.
You could have just had the shared the desktop and just kept it there.
Well, that's where it is on my desktop.
Well, click share screen and then choose desktop. And we'll see whatever you see, we'll see it. So go and find your spreadsheet.
It's here.
Okay, click it, we can see it.
Yeah, I think it's here. Yeah, no. Card, Lagrange, board.
Get your gosh, what is it on the Mac? Alt tab, command tab.
There it is. The biggest problem I'm having is that the what I would like to just click on is again part of the menu bar.
Yeah,
of Zoom.
there's ways to hide that. I just don't
Just
remember.
grab the menu bar and move it to
Oh,
a different part of the screen.
Yeah, you can drag it somewhere else. The bar.
Okay. Good to know. All right. So here we're back to Gaia, talking about Gaia. And it has, I've got a bunch of links here that you could investigate about Lagrange points, how many objects currently are in Lagrange points. The other thing I would like to talk to you about is a special orbit that was chosen for Gaia that is what's called a Lissajous orbit. You can see one forming here. So here's Earth over here. We're going to launch the satellite. The satellite's going to go to L2, away from all the space junk, and at a spot where we're not going to have to use up a bunch of gas on the satellite to keep its orbit stable. And then we're going to let it orbit around L2. And as it does that, it makes kind of an interesting geometrical pattern. And the advantage is, if I had a telescope on board, I might be able to get multiple pictures of whatever I'm looking at, because it just repeats that pattern. So that's a particularly nice aspect, to have an orbit that's called a Lissajous orbit. Again, I've got a link to that. And so here are some of these links. Again, because of time, I'm just going to go on. The telescope, the Gaia telescope, also has a 3-mirror arrangement. It's a lot like a Schmidt-Cassegrain arrangement, except that there are 3 of them. And so it's kind of an amazing thing. I'm going to try to have you watch a YouTube video right quick.
Gaia looks at 2 patches of the sky.
All right. Here's how the camera on board the Gaia telescope does its work.
One billion stars. This is the number that the European Space Agency mission Gaia will reach, mapping each star over 70 times to nail down their position, movement, and characteristics. In the end, we will hold in our hands the most precise 3-dimensional map of our galaxy. But how exactly will the mission measure such a vast number of stars? With its 2 telescopes, Gaia looks at 2 patches of the sky at the same time. A series of mirrors guides the light to the camera, the most powerful camera ever flown in space, with 106 CCDs and almost 1 billion pixels. When light from the first telescope reaches the camera, the first column of CCDs in the star mapper, on the right, selects the stars that will be followed and measured. When light from the second telescope reaches the camera, the second column of CCDs in the star mapper selects the stars that will be measured. As Gaia scans the sky, the light from both telescopes moves across the camera. But not all data need to be read out and stored. The onboard computer assigns a small patch or window around each star. As the image of the star moves across a row of CCDs in the camera, the star's position and brightness in this small patch on each CCD are recorded. This method is an optimization to deal with the enormous amount of data collected by Gaia's camera. Only a few dozen pixels on each CCD contain information about the star, so only those are read out and the corresponding data are stored. The largest section on Gaia's camera is the astrometric field. As the image of a star moves across its 9 columns, Each CCD measures the star's position and brightness. Then the starlight passes through two special prisms that direct different wavelengths to the two columns of CCDs in the photometer. This provides information about the star's temperature, size, and chemical composition. Light from a subset of stars also reaches the radial velocity spectrometer, 12 CCDs that are used to measure how fast stars are moving with respect to us. For each star, the information collected by all CCDs is compressed into a data packet and stored in the computers on board Gaia. This process is repeated over and over for each star. An average of 2 million stars are measured every hour, generating a total of about 50 gigabytes of data every day. This is equivalent to more than 10 DVDs worth of information every day. The data packets for each star are transmitted to Earth, where they are received at the European Space Agency's ground stations. The data are processed and analyzed by astronomers, who use them to investigate the three-dimensional distribution and physical characteristics of stars. When all this is done, Gaia will have created the most precise three-dimensional map of our galaxy, the Milky Way.
Okay, well, that's kind of how the information is collected. I think it's amazing that it's collected autonomously. Get this out of the way again. Okay, there is one other thing to show you very quickly. I guess two things. This particular website I found and really liked it because it showed with a picture and a graphic. This is obviously not the Milky Way, but it's a picture of a galaxy very much like ours. So when Hipparchus was sent out, the measurement of certainty that we knew gave us information about the distance to stars in our backyard, so to speak. Gaia, you could see the capability it has. So with that satellite, the area that we could find out information about stars really expanded. But the green arrow or the green ring shows the possibility of where we could accurately gather the information. I'm not trying to suggest that every star in this green ring is a star we know information about, but rather the technique is so good that eventually we could find accurate position information about everything in that ring. The significant thing to me about that is it means that we could look to the center of our galaxy and know a lot of information about these stars, not only where they are, their color, surface temperature, their age. We get all the information that you find on an HR diagram comes from this sort of gathered data. Okay, this is an interesting article to look at too if you're into the math end of it. This person does a very good job of including the uncertainties. All right, so we've looked out there. We think we can determine the parallax, and we think we can calculate how far to the star. But there are uncertainties with all these measurements, and so this particular argument does a very good job of talking about the uncertainties. Sadly, way back when, the symbol used for the parallax angle itself was pi. What a choice. Okay. I'm going to get back. The thing that, let's see if I want to stop sharing this. I don't. I have one more thing to share. So I want to go back here. You know, the reason this is so consternating is that I just go back and forth between one app and another, and I know I can't do that here. But it's hard to find my way around. Okay. Let's see. The other thing that I would like to show you about this is a little bit of a conference. I found this link to a conference, and the man who does the narration is just very easy to understand. I think I'll end with this just for a couple of minutes, and then we'll just have to call it good. So I hope that you enjoy this as well. Anthony Brown is this man's name, and SPIE is a very interesting digital library, all things optical. So we'll take a look at this, I think. If I can get myself on the right foot, here it is. I also thought it was.
Hi, my name is Anthony Brown from Leiden Observatory in the Netherlands, and it's my pleasure today to talk to you about the Gaia mission. Just 2 weeks after we published our latest data release, Gaia Early Data Release 3, and this was on the 3rd of December.
I just find this interesting because, and probably you guys have tried this before maybe, but the text, the little cursor follows along, and so it makes it particularly easy to look, to stop conveniently when you want to. So he's going to talk about the precision of the Gaia satellite. Go ahead, Anthony.
I start with an overview of the Gaia mission. On the right, you see two images, the Gaia spacecraft on top, and on the bottom, you have the payload as it was being ready for vacuum testing prior to launch. The Gaia spacecraft consists of a large 10-meter diameter sun shield, on top of which sits a 3-meter tall cylindrical structure, which houses the service module as well as the payload. And you can see the two apertures of the two telescopes that Gaia carries. As you will see in the bottom image, the main mirrors of the telescopes are rectangular in shape, and we will come back later as to why this particular shape was chosen for Gaia. The goal of Gaia is to collect astrometry as well as spectrophotometry for well over 1 billion objects, as well as radio velocities for the 100 million brightest of these. The survey itself is OAS Full Sky, and it's complete out to about magnitude 21, and it's based on an autonomous observing program carried out by Gaia. So it does onboard detection and autonomously decides which sources to measure. Over the course of a 5-year mission lifetime, this results in about 70 observations on average per source.
So I want to stop there for just a minute and remind you that the orbit that was chosen for the Gaia satellite is this Lissajous orbit. It looks like sort of a tube, and all the lines represent a way to gather information about the entire sky. And so part of the wonder of all this, besides the fact that the telescope is choosing on its own which stars to look at, is that when it chooses a star to look at, it's going to look at it 70 other times, 69 other times, 70 altogether.
Launch of Gaia was in December 2013, and it has already had its 5-year nominal mission operations in its orbit around the second Lagrange point. And the mission has been extended until the end of 2022, so we're already in the extended phase of the mission with an indicative approval to continue until 2025. And in 2025 is when we estimate that the fuel for our micropropulsion system will run out. And once that happens, we can no longer carry out the accurate observations that are needed to collect the astrometry for the Gaia sources. Given the current health of the spacecraft, we have no doubt that we will actually make this 2025 timeframe, meaning that we will have not a 5-year mission, but actually a doubling of the mission life out to 10 years.
I'm going to stop for a minute and I'm going to skip ahead. here's what I was talking about, those multiple orbits. So this angle is maintained, the angle to the sun is maintained, but the whole telescope is going to rotate around that axis. And as it rotates, you can see it's going to cover more and more and more of the night sky. That's how it can find the stars to look at again, and look at them as many as 70 times. One of the things they talked about that I thought was interesting is they control the angle of rotation of the telescope so precisely that when a micrometeorite hit the telescope and caused it to ring a little bit, they could see it. That little piece of rock. And of course, they had to have a way to get it back to vibrating just the right way. Here's another thing that's interesting, the sensors. The sensors look like they're nice and linear, but the problem is that they're being degraded by the sun. And so they have to take that into consideration, that the sensor itself has to be kind of readjusted. I'm trying to speed up. You can see that the slope is the same, but the y-axis intercept is different. I'm kind of speeding ahead here. One of the things that they've been able to do is to make some conclusions that were just impossible to do. They were theories. No one had any data to support it, but the positioning of this telescope is so precise that astronomers were able to come to some conclusions that would have been impossible otherwise. Oh, come on.
And this means that the cooling down of the white dwarfs temporarily is halted because of the extra release of energy. And this leads to the pileup of white dwarfs around this absolute magnitude. And this is the first time we have been observationally able to prove that this process actually happens. And this is thanks to the very exquisite parallax measurements that Gaia provides. And then the final example is that of the Sagittarius dwarf galaxy and its effects on the Milky Way disk. So this is a dwarf galaxy which is in orbit around our own galaxy and has in fact already gone around a couple of times over the past few billion years. And what you see here is work that was done by Ruiz Lara et al., who examined the color magnitude diagram of the solar neighborhood in order to derive the star formation history of the Milky Way disk. And what they notice is that every time the Sagittarius dwarf galaxy passed through the Milky Way disk, there was a peak in the star formation history, so showing a very direct influence of this galaxy on the Milky Way disk. And in fact, the disturbance caused by the passage of the Sagittarius dwarf was noticed in a paper that appeared very soon after Gaia DR2, in which this very famous now phase spiral was published, which is the distribution of stars in the plane of vertical motion versus vertical position above or below the galactic plane. And in that plane, you see a beautiful spiral, which is a sign that the disk is not in equilibrium, but is still relaxing back to its equilibrium.
I'm going to just go ahead and
generate with the.
I'm just going to stop here. This is a technical paper, as you can tell, but I think if you just don't look at the math so much and look at some of the graphics and conclusions, the Gaia satellite is probably has given us the largest amount of information of any satellite, maybe even compared to the Hubble telescope. And I think the James Webb satellite telescope is probably going to do the same thing. So I think I'm just gonna quit here. I think we have to have time for a meeting, business meeting. And I'm just gonna leave you with this graphic again. Now, it's not quite the last one, is it? There's what I'm looking for. So to be able to look at stars near the center of our galaxy and find out information about them reliably, know their position, know the astrometry, know their position, and spectrophotometry to find out what the spectrum of each star means, and to put that spectrum on an HR diagram. These are things that are going to let us find out at our choosing information about stars in that circle. I'll leave you with one thought. As amazing as this is, Gaia has found out information. Even after collecting a billion information on a billion, almost 2 billion stars, it represents about almost 1% of the stars in the Milky Way. Okay, you might have some questions. If you do, I'll try to answer.
You want to unshare your screen?
I didn't hear what you asked.
Can you unshare your screen?
Oh, yeah, that'd be nice.
Your wonderful face.
Stop sharing. Okay, I'm sorry.
That's okay. Any questions? Yes, Sonali has a question.
So how many telescopes are there at L2?
Okay, one of the links that I showed you shows all the satellites currently at L2. I don't know what the answer is, Sonali, but again, the thing I'm really hopeful is that you will, because this compilation of websites is on the OAS webpage. So I hope you go there. It'll say clearly a list of all the objects currently at L2.
Any other questions? Mike has a question. You have a comment? Okay.
Yeah. Listening to Steve's talk on space telescopes brought to me a memory of the latest reflector that has an article called The Mega Constellation Threat, which I had no idea what that is. Maybe you do or don't. It's
Yeah,
talking about all the satellites that are going to be launched and that are being launched and will be launched. And one of the things that struck me, they said that the pollution that these satellites can cause will even affect photography from the Hubble. And it's happening now, actually.
Yep.
And I never realized that. And you have to read the article to get it all out of there.
It's
But
been
the
a
bottom line
topic
is-
of discussion for like the past 5 or 6 years.
Yeah, well,
In the last 3, it's
according
been
to this
really big.
author, it's happening quickly. And
Oh,
the
yeah.
amount of satellites that are going to be launched in the future are mind-boggling.
Well,
And you should read this article.
well, yeah, SpaceX was initially going to be 12,000. Now they're talking 40,000.
Yes, they are. And there's another group that's that has in there. There's another 44,000 going up.
Mhm.
And they have protection, so it won't do what it's doing.
Uh-huh.
But they said at times the satellites will either blow up or degrade or whatever, and it will catch the light and it will wreck the photography that you want to do. According to the end of the article, without you don't want to read it, it's basically said it's going to change astronomy forever.
Mhm.
And that's kind of depressing.
Yeah. It's
Sorry,
just like
Steve.
light pollution by. So
But that's what made me think of it.
if there's any more questions?
I have a comment.
Yeah.
Steve, you talk about Rear Commodore Grace Hopper a lot. She does all kinds of things, and I carry around a light nanosecond with me often too. But being a computer nerd, I'd like to point out that she was also a member of the team that discovered the first computer bug.
Yes, she sure did. It was a moth that was caught in a relay and preventing things from working. And it was literally a bug.
Yep. She's an amazing woman.
Yeah. What I liked about what she did was she was not going to sit still for the complicated language needed in order to program. And so she was a really, really strong advocate for COBOL as a way to use ordinary language that would be understandable in order to program.
Thanks, Steve. Can we get a round of applause, please?
There's a lot more there. I hope that you that you find this spreadsheet and just really investigate it at your leisure over a long period of time.
Thank you for working
All
with
right.
that online as well.
Well, thanks for walking me through this, finding where I needed to be.
You're welcome.
I think sometime it wouldn't hurt, I think, to have a little tutorial about it. The really hard part is that I can't do it by myself. I need to be connected to a Zoom that's happening.
I would certainly help anybody who needs assistance on doing presentations as well. So,
all right.
Okay. I'm gonna run through this real quick. Let's see, that's done. I don't need that. Brief secretary's report. Boom, 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 boom.
Big event in the December meeting, of course, was the annual Christmas party. Had a virtual and live meeting, virtual via Zoom and live at King Farm. We had the Santa Goes to Space, and it's going to be held at the Sac Museum on December 4th in Astronomy at the Park. One award, Mike Mondrin got Astronomical Lead Outreach Award, David. The usual monthly presentation, Comment Leonard was kind of the big star for the month. Also program or tool time, and in lieu of a regular program, we had the drawing for door prizes and the Christmas party.
Okay. Is there any corrections or additions to the minutes as we read them off the screen and had them briefed? Is there a motion to accept the minutes as read? Mike Moderson and Cleet seconds. Motion has been made and seconded to accept the minutes as read. All those in favor say aye.
Aye.
Opposed? Thank you. Treasurer's report.
Well, in December, as you can see, we had an income of $123.76 in dues. And we spent $58 for postage stamps, which I have, $45.95 for handouts that John Johnson had printed for a program out at the Air and Space Museum. spent $1,278 at the holiday party, more or less, between $591 for food, $300 for door prizes, and excuse me, $386.76 for door prizes, and $300 was given to for the use of the property. A total of $1,381.96. And the balance at the end of the month is $14,605.11. And so far this month, there's been about, I think about 9 people who have paid dues. And we've been kind of steadily getting some new members who sign up by going through PayPal and just see us online or whatever. And I would say that's everything.
Thanks, Mike. And if anybody here needs to pay their dues, you can get them to me. I will be proxy for Mike and get that to him tonight. I mean, not tonight. I'm not driving over there tonight. I mean, I'll accept them tonight and then get them to him. Rodney, how's Astro Park?
I hadn't been out there. I was gonna go out there tonight and had a minor disaster that happened. That's not a couple hours on the phone, fixing that, and getting out there. I'm not sure if it's passable or not. I'm also gonna park out there and walk down, but I did have lighthouse service.
Do you remember when that was?
Was the first part of December.
Okay.
Notification on my phone, my calendar.
I only ask so that Mike has an idea that something's going to be coming.
Yeah, no, I think it was, it was like tail end of October when I called it. So, but,
I'm not able to hear what's going on, so.
He's talking about he had called for service for Astro Park.
Yeah. And when?
Roughly around November, December-ish, early December.
Yeah, you know. I wonder if like Bill got lost.
Yeah, we've only, according to the records, we've only had one service this year from a bill perspective. So they may not be sending them in timely. That's what we're thinking.
I might have to check with them.
Okay. Maybe if they have a statement that they can, for the last year.
I called them like on a Friday or I called them on Thursday. He said it might be done tomorrow. If not, it'll be definitely done by Monday.
Okay.
They're saying they haven't sent the bill yet.
I'm asking to have a statement sent for the last year so we can try to match up for any bills. Rodney's going to call them.
Okay.
Double check.
All right.
I feel like I'm talking to the heavens. Finally, an answer. No, you got to stay home and work on your homework. Thanks, Rodney. Ladies and gentlemen, one of the most important things that we have to do every year, budget. I have not exactly changed any of these numbers on income. So let's take a look at what we got. Where did I put that? Okay. So for the past year, we took in $1,575 in dues for family in the mail and $1,571.11 from PayPal. The difference in the number is when a renewal is done online, there is a fee that we are paying as part of that. So it gets trimmed off the top of the dues. There was one student due of $10. Some input from or income from the outreach events that we've done this year. Rent from buildings at Astro Park. We had some cash donation. Other income through Amazon Smile through that donation program. If you're not familiar with it, you can set a nonprofit organization to receive funding through your purchases on Amazon. So for me, I have Omaha Astronomical Society selected as my choice for who will receive it. And we get income from that. Expenditures total about $3,474.43. So that's roughly, close. And so dues, let's get that updated. Go out of the way there, Zoom screen. Oof, I'll have to total all that up. So roughly.
Well, the totals are there.
Well, I was just doing totals for dues specifically for the line item, but yeah, we'll just say 3,000. Thank you. So we didn't do any calendar sales. We really haven't done it because of meeting. I'm sorry we haven't done it, although I'm not sure if we've missed it because you can still get those things.
Yeah, that's in the reflector.
It's in the reflector. Okay. Outreach income. We were a little bit different this year. The events were sort of spread out. So I'm just going to put that at 500 just to split the difference. We don't know how this year's going to be. Rent is up. So that was 118. So we'll just put 120 to make it even. Easier to read that way.
That was the PayPal fee.
What?
That was the PayPal fee. That's why you don't have 120.
Oh, because somebody paid rent through PayPal?
Through PayPal. Oh, yeah.
Okay.
Then we don't get $30.
The miscellaneous. So 3680. C11, yeah, that's right. Expenses. So we have essentially 300 allocated to the lighthouse, which is roughly $48 a piece. So that gets us 1, 2, 3, 4, 5, 6 a year. Mowing is 600. However, what was it?
It was 450 this year, but I think that 600 is very reasonable.
Okay. Maintenance to the road, that's in case we need to get rocks. That's why that always usually stays there. Star Party, should we do that 500? Okay. So that's Astro Park. Astronomy Day, 75 bucks. That didn't happen last year, did it? No, but you never know. Dues are the same for Astronomical League, if I remember correctly. Is that right, Mike?
Pretty close. I think it was right in there this year.
Okay.
I mean, you can find it pretty easily.
Okay.
I think it was 800. Wait a minute here. I thought it was 800. Expenditures. 800.
Okay. Awards?
I think they raised it.
$75. I didn't know you had a budgeting thing. That must be for your frames there, Cal. Calendar purchases we didn't do. Do we just keep it just in case we do it next year? Okay. Education scholarship is 200, which we have not done in the last couple of years. If you remember, we did do an event right before the pandemic hit. And we said, we'll bring you in when we can be back in person again. And that's been 2 years. I don't know, they're probably in college, so. IDA membership is $100. Holiday party refreshments and door prizes, 200 and 500. But that was just for that one moment that we voted it up. So normally it's going to be that. IDA membership's 100. The insurance did go up. I just rounded it up to 330. Office supplies 80, post office box 70. I threw a postage line item in there just in case. That did not change for the presidential discretionary expense. Got to get that word correct. Program expenses, $300. Refreshments, 100. Stella website, domains and emails, 200, which I just confirmed today. And I'm getting ready to pay that coming up tomorrow or in the next week. Telescope repairs. Stafford, do you think the number looks good? Okay.
What we have done, though, we've gotten a few more in. I think one of us to get the best use out of it will be the better value for the
There'd be like another one of those talent cell things, probably. Okay. We can leave it at that number.
I would say do that because I think that would cover some IP still in. Expand on collection a little bit. There's nothing really in the repair forecast.
Okay. I couldn't hear you, Nina. I'm sorry, you're out of my field of vision, Louis.
Oh, I noticed earlier the budget heading for expenses for 2021.
Thank you. I don't write checks much anymore, so you kind of forget.
Which leads me to wonder what's the income subheader also?
I already had it 2022 on that one.
Okay.
So I'll get partial marks.
Yeah.
Okay. We've put a line item on here for Zoom. And I'm going to leave that there in case we need to exercise that option. What we have right now is working well. Like I mentioned earlier about the UNO contract ends in May. And we're not sure how things are going to go. Right. I think that it didn't go through August as part of the initial run up, probably because they're not sure how things are going to be for the summer. That's probably why they didn't do the full 12 months when we did the sign up. Okay.
They don't do anything.
Right. So if you're not familiar with that process, I got to sign these long documents about, yes, we use the space and what we can and can't do here, as well as the insurance coverage of liability that we have to include the Board of Regents for that. So the planetarium, thank you, sponsors us to be using this space. It's been a long, fruitful relationship we've had for many years. Personally, I've been coming to this room probably since 2007. So that gives you an idea. I don't know how long it was before that. 1995. So it's a long relationship we would like to continue and cultivate. So I'm just going to leave it there. If we use it, we use it.
Yeah, well, it's a nice option because it allows people like Janine and Kendall saying.
Oh, I mean, this is like getting our own account. Yeah.
But what I mean is I think we might want to make sure that we always can have our own account.
I think we will continue to do hybrid meetings pretty much in perpetuity. Yeah. It allows us to have reach. We have recordings of the meetings so people can watch them if they've missed them. And it allows others to join us and do presentations as well. It works very well for us. Kind of took COVID to kick us a little bit, well, we were always there with our telescopes. I mean, that's the past, but the future. So, yes. Yes. So, looking at the expenses and the income. Is there a motion to accept the budget as presented?
I think the
Yes,
post office,
Is there, what is the issue with the difference in income being half of the amount of outgo? Anybody have a problem with that? I'm not saying I do. I'm asking if anybody does. We have enough money.
We have enough money.
That's not an issue.
The biggest thing to remember on something like a budget is that that's not exactly gonna be money that has to be spent.
True.
It's available to be spent. Like John didn't use any of that discretionary expense. that
No.
He has,
Well, it's
Or the
not
calendars.
The whole 700 he
Right.
had available.
right, so it's just a guideline.
Yeah. So is there any time that we actually see what the annual expense was? Did we, is that what we looked at there? Okay, okay.
yeah, I don't know where the post office box is on that. I'm kind of wondering how that got paid. Because in a year, I must have paid that. And I think it was $110. I think they raised the price of the post office box,
Okay,
but I'm going by my memory. And I'm wondering why I didn't find it when I was making the list.
that's true.
But even the outreach we had wouldn't have made the 3,000.
Yeah, yeah. Now, like we haven't done rock for several years. And it's sort of there just in case we suddenly have a washout, right? So,
No, I'm fine with all of it. I just wanted to be sure everybody noticed the discrepancy.
okay, very good. Yes, that's important. Krista.
No, the last couple of months you had mentioned that we're celebrating a big anniversary and.
Oh my gosh,
And it's not expensive.
that's a good point.
I mean, it was gonna be a big semi-formal.
Yeah,
Gala.
Yeah.
Oh, yes, Dolly.
well, here goes the budget.
Okay, how much?
I don't know how much the last one cost.
Thank you, Bill.
Well, we went into the background and we talked
Yes.
about the invite and how much.
It was like $50 a piece for the income for place setting, right? Is what we thought. I think it's what it was for the 50th, was $50. I know.
$3,000.
We have the money. Whatever you want.
Now that'll probably get broken up. We don't have individual components like this is what the room costs, this is the food cost, this is, and it's going to be offset by, gosh, do I need to put something under income for place settings?
Oh, ticket, yeah.
Yes.
If it's going to be.
It's,
Well, that's what has to be. That's what has to go. We can always get it catered.
Hy-Vee, call Hy-Vee.
Works for me.
$2,000.
For tickets?
Half of it.
Okay, all right.
50.
How many members?
Don't know.
50?
$1.5.
$10.
I don't know. Last time we had, we booked room. Again, conservative estimate. Yeah, something like that.
Woo!
We had quite a few people.
Oh, yeah.
It wasn't insignificant.
No.
If it was a $50 a ticket, that's like
Yeah.
$5,000 if it's 100 people.
You won't get 100 people.
No.
No.
Yeah.
If we make more money, it just makes it less time. Right.
Yeah.
So I don't think we need to.
Conservative estimate.
Okay. It changes. Amazon Smile changes. It's just there as an item, so it's extra that we get. So
1,500 isn't included in your total projected.
yeah, since I added the row, I gotta change the
Oh, yeah.
13 there.
Same thing in the expenses. You added the 3,000.
32. Come on, edit. Hoi. Okay.
That can't be right.
Expenses were never that high.
You know, that's in my head, it's a lot less than
It's-
that.
What's that, Mike?
Yeah, way to go,
Well,
Joe.
that's not added correctly. Unless I can't see it all.
What's that, Mike?
Well, maybe I can't see it all. It doesn't look like it's the correct number, but I can't see the whole column.
Oh. It goes up quite a ways.
Oh, it does. I see that.
So like
Maybe it is that much.
11, so we begin on.
Yeah, no, that's probably right.
Yeah, because the Astro Park is a subtotal from above, so it's separate. That's why it's
Oh,
that way.
I don't know how to do that.
So
Should we consider calendar sales as an income since it's an expense?
Well, you spend money and you take money in.
We earn money,
So you're in practically nothing selling calendars.
calendar sales as
We
well.
paid this, we paid for this, some of the calendars. We didn't earn money on
Okay.
calendars.
It says 0. I was just wondering.
Yeah, no, I don't know. I don't know why you got it down there as this expense, but we take in as much as it's
Yeah,
close to break even, but it's not
Yeah.
break even. And certainly the OAS doesn't come out ahead.
I can answer
Okay.
that.
Used to make
Yes,
money when
Nina.
I was a president.
Calendar sales is in both columns or both income and expenses. Because as calendars are ordered, they must be paid for.
Ah,
People receive their calendars, there's a little bit of money that OAS earns off of those.
Like $2.
So, yeah, like $2 or $3 worth. So we
10% more.
do have to pay for them, but in the long run, we earn money that becomes income.
I think you may have done that in the past, but I don't think we did it when I've done it.
we haven't really ordered them, have we?
Not the
Yeah,
last time.
yeah.
Oh, yes, we have ordered those that we did not make money.
Okay.
Now, in the past, they probably did, but
We paid
not in
$7
the 2 or 3 years I did it.
Oh, well.
John, if you've got 300 for outflow for calendar sales, you probably should have some income for calendar.
Actually, it's 550, I think, for calendar sales, the expenses.
We maybe ordered 15 calendars. At $10 a piece.
No,
Sales would be a debit
if you
and a
really want to
credit.
know, I of course can look it up because I have the information. I just can't do it real quick like we're sitting in a meeting here.
I understand.
It's a budget, make them both 200.
Yeah,
There you
no, that's break
I
even.
don't think they cost very much to sell them to the people, but we didn't make any money. Club didn't make any money.
go. Make it even, yeah.
yeah, even. That works.
Okay, now we have.
I move to accept the budget as written.
Nina Baker.
Who was the second?
We haven't had a second yet.
I'll second.
Bill, seconds. A motion has been made to accept the budget as shown on our spreadsheet, as written, and seconded as well. All those in favor say aye.
Aye.
All those opposed say nay. Thank you. Oh,
Yay.
yay.
We got it
We got
done for
5
this
minutes.
year.
Real quick, I know we got 5 minutes. 60th anniversary. Probably gonna be the focus of the next board meeting, as well as the OAS meeting. So if folks are interested in attending the board meeting to listen in, you're more than welcome. It's just gonna be a discussion. We normally used to have the board meeting in here the first of the year for everybody to see or participate. They're more than welcome to. The holidays kind of got in the way this year that we couldn't really have it before the meeting this time. But yeah, I would like to discuss the 60th anniversary soon.
Are you gonna do it by Zoom?
Yeah,
Mhm.
by Zoom.
Will you let us know when the meeting is?
I can, yes. I can even send out a special separate email to the Stella mailing list to have that information.
That'd be great.
I better make a note for myself. Because we made a big list of places. I think that was in October, no, it was November.
Yeah.
Yeah.
Did we volunteer John Johnson's wife to help us? He wasn't here. Yes, we did.
Yes, we had a whole bunch of names.
I was wondering if that came up.
Yeah, oh,
did.
yeah, it did.
That's
what happens when you don't attend.
Uh-huh. We were in Arkansas. I should have zoomed.
Yeah, you got voted in without being here.
Yeah.
Oh, yeah, you did. I was right.
What kind of crowd this is?
All right, we got 3 minutes.
So it was.
Krista, do you recall how many people we had maximum on Zoom?
For you know,
22.
300.
22?
I looked, the last time I looked was 20.
And there's 4 of us in Zoom right now, so that's 18. Because Louis was in, I'm in twice, and Krista's in, so.
I have 23, I had 23 max online tonight and 19 people in this room at one time. Tonight.
Oh. very good.
19 would be about right there. if you
Getting that
subtract
for
4.
Diana, so she has the number.
23 in
I got it on
person,
sticky
19
note
on
just to
Zoom.
hand it to her.
Yeah,
Yeah.
19 in person.
19 in person.
There were 23 entries in Zoom, but 4 of them were from
I
this
just,
room.
yeah, I just counted 23 had logged in because we did have a couple of couples and then a couple of us
Oh.
logged in twice.
Very
right?
good, yes, that's important as well. Friday, February 4th, 7:30 PM on the Zoom, ladies and gentlemen.
channel.
I'm gonna do this, end it. Thank
Motion to
you.
close.
Oh, that's right, thank you. Second. Bill and John Johnson. Motion to close the meeting and seconded. All those in favor say aye.
Aye.
All opposed today?
Thanks, John.
You're welcome.